Brian kind of gave you the overview, and now we're going to kind of dig a little bit deeper into sort of the different types of offerings that are out there, and how private, hybrid, public, what the offerings are from a Microsoft perspective, and how we can start to take advantage of some of these solutions. And so, Microsoft's been talking about Core I/O for a long time. I come from Microsoft, and when I started in 2006, we were talking about core infrastructure optimization, and you know, that time was all like, you know, hey, you know what, you really need some group policies, you know, group policies, desktop standards, you know, firewall, lock down the perimeter. It was really kind of, you know, at the start was just trying to get people to, you know, a standardized desktop was kind of like the ideal goal, so that you had firewalls in place to protect the perimeter, you had some security policies, group policies, and really started kind of trying to control what users could do with their desktops. A little difficult with Windows XP to control what people can do with their desktops when they have to run as full administrator, but it was a nice idea. Just kind of came along, it kind of grew as the System Center suite of tools kind of grew, and we got things like SCCM 2007 and the ability to do zero-touch deployments. By that point, you know, people had kind of gotten onto the security train. You know, XP Service Pack 2 and Service Pack 3 did a lot around that to sort of lock down security on the desktops a little bit better. And really able to get to this, what they termed as a rationalized state with some of the basic System Center tools that were out there, right? We could do monitoring with MOM or with SCOM 2007 and get an idea of what was going on in our environment and become a little bit proactive as far as management went. You know, I mentioned zero-touch deployments. This was around the time that virtualization was starting to take off, and we got things like Virtual Machine Manager to provide that same sort of management experience that we would have over desktops and physical servers in the virtual world. But the tools really weren't tied together very well. You know, if we take a look, we had Virtual Machine Manager 2008 R2, Configuration Manager 2007 R3, Operations Manager 2007 R2, Service Pack 1, Service Manager 2010. You know, there was a real mishmash of different types of components, and they didn't really tie in very well together. There was a company called Apals, which made a third-party tool that would tie these things together, but it wasn't very well known, and it wasn't very well adopted. And so getting into this kind of dynamic stage of this integrated environment with automated self-service, you know, it was a nice idea. The tools weren't quite there to really deliver on that. And so it really became difficult to kind of get to that point. I mean, over the time, you know, we were able to kind of move up the stack, but again, that dynamic stage was really difficult. Over time, you know, Microsoft renamed this a couple of times. I think at one point we were calling it Dynamic Systems Initiative, which was Core I/O, which is sort of a fancier marketing name. To an extent now, you know, that's really what private cloud has become, or cloud computing. It's a lot of the same concepts we talked about you know, way back when. The technologies around it have changed. And again, as I mentioned before, you know, when we talk about cloud computing, everybody thinks virtualization, but when we look at sort of the tenets, you know, agility, economics, focusing IT on providing services, and, you know, some of those concepts around, you know, pooled resources, elasticity, self-service, usage-based, we start to see this kind of, you know, opportunities show up in different areas. You know, I mentioned, you know, application self-service, you know, and that being kind of a cloud computing service where we have a portal where a user can go to and they can request an application. So that takes care of the self-service part of things. But we can also put, you know, usage-based scenarios into play there where, you know, they request Visio or Microsoft Project or something like that. And those are, you know, sort of limited licenses. We don't have a site-wide license like we would for the Office suite for those applications. So somebody needs Visio, they only need it for 3 months. We're not going to spend a few $100s on a license for Visio when the user only needs it for a few months. So we'll lend them the license, you know. So when they make that request, they can specify how long they need that application for. And when that time period expires, we can kill off a VM, we can remove an application, we could, if it was a user request, maybe it's a contractor, we can expire their Active Directory account. So there's a number of different, cloud computing type solutions that really come into play when, outside of virtualization, when we get into the technologies. We talked about this a little bit, and when we look at the cloud services available for Microsoft, again, there's a lot of similarities. So the Windows Azure platform in the public cloud is essentially the same as what you can build privately. In fact, there's something now for Windows Server 2012 R2 called the Windows Azure Path for Windows Server. Nice long Microsoft tongue twister. That allows you to actually build your own Azure software as a service provider on-prem. So, we really start to see these two things being tied together. And beyond that, we're all familiar with things like Link and Exchange and SharePoint. We're running SQL. Some people may be running Dynamics. All these services are available online as well. So Office 365 is sort of your Link, Exchange, SharePoint offering. There's CRM online, things like Windows Intune and expanding management. And then just through the Azure services as well, you can run SQL reporting, you can run full-on SQL services in the cloud, and they're all based on sort of that common set of technologies. So SQL running on-prem is the same version of SQL and the same sort of capabilities as you have in the cloud. Hyper-V running on-prem now with 2012 is the same thing as you have in Azure, and even the software-defined networking that has been in Azure for as long as the infrastructure as a service was in preview mode and now released, is something that we can build on-prem with Virtual Machine Manager. And as we get into R2, that's where we start to see the tie-in of sort of connecting those networks. And so some of the real changes on the R2 side of things is all about having your private cloud built on System Center and Windows Server 2012. And tying that into a hosted environment, so somebody like a Rackspace or a Rackforce. And as Brian mentioned, the next sort of step in that idea and in that concept is tying that into Azure so that we can have that, that sort of hybrid solution. We can do a hybrid, have virtual machines running in Azure and have a VPN network from your Azure service to your on-prem, so those virtual machines can be part of your domain. But right now, there's no way to sort of dynamically move machines back and forth other than just uploading the VHD file and downloading it manually. And so we'll start off taking a look at private cloud, and we'll sort of get into public cloud and then in hybrid scenarios. On the private cloud side of things, it's really two different technology sets. It's System Center and it's Windows Server. System Center over time has sort of grown to really kind of allow for this to happen. As we mentioned, there's been a lot of different products and technologies that Microsoft has built, acquired, rebuilt over the years. We go way back to SMS, became Config Manager. MOM became Operations Manager, and new technologies like Virtual Machine Manager and Service Desk, which became Service Manager. A lot of changes have happened in those product suites, but up until the 2012 release, they were all individual products. They didn't tie in very well together. And in 2009, Microsoft bought a company called Opalis. They're actually based here in Toronto. You'd actually be surprised how many Ontario-based companies Microsoft buys. It's pretty astounding. Opalis is one of those, and Opalis was a company that basically did IT process automation. So their tool tied into all these different systems, Microsoft systems, third-party systems, and allowed you to build processes and automate tasks between these different tools. So you could use like BMC Remedy you can use Opalis to basically take an alert in Ops Manager and create a ticket in BMC Remedy as an example. So Microsoft bought it, rebranded it as Orchestrator. It hasn't changed since that time period, other than more integration packs coming out to integrate with additional systems. But it really hasn't changed. If you look at Opalis and you look at Orchestrator, the only thing that literally has changed is the name in the MMC console, and the web-based portion. They switched it from Java to Silverlight because they don't really like Java very much. Although that's changed with the Oracle announcement last week. But really, to get to this sort of cloud type of scenario, this sort of mismatch of different tools made it difficult. And so in 2012, they kind of brought everything together as a suite. And so System Center 2012, all components were released at the same time. Service Pack for all those components came out at the same time. And as we get into this R2 phase, you've probably heard a lot about Windows Blue and the Blue Wave. System Center, Windows Server, Windows Client are all now on the same release cycle. So it's back to NT and Windows 2000 days, where you've got the server and the client and the management tools all at the same time, which is nice. When System Center 2012 came out, Windows Server 2012 wasn't out yet. So when Windows Server 2012 came out, System Center didn't support it. You had to wait for Service Pack 1. And then Service Pack 1 for System Center came out, and finally you had the ability to manage those devices. So with R2, Windows Client, Windows Server, System Center will all be released on the same day. So out of the box, you'll have all the integration across those points. And again, that's targeted for the September-October timeframe. And one of the things that they're looking at going into, and really the strategy going forward, is smaller upgrades but more frequent. So we'll go into this. From System Center 2007 to 2012 was a huge change. Lots of big migration projects. It wasn't like you could just install the SCCM disk, click migrate or upgrade, next, and wait, and 30 minutes later you were on Config Manager 2012. You really were building a new Config Manager environment, migrating everything over, migrating all the clients over, and they're fairly large projects. The idea is to simplify that and actually have it being an in-place upgrade if you want to go that route, but also then have those happen on a yearly cycle, as opposed to every 3, sometimes 5 years for these migrations to take place. That's the idea, that's the goal. We'll see how it works. It's quite the challenge when you take a look at everything from Azure to System Center to Windows Server to Windows Client, and trying to align all those different teams with updates. But that's the idea. One of the other big changes with System Center 2012 is licensing. You used to be able to go out and buy Ops Manager, or just go out and buy Config Manager. Now when you buy System Center, you get the suite. So you get everything. So there's good and bad to that. If you only want Ops Manager, it's going to cost you a little bit more than just having Ops Manager before. But if you're looking at buying Ops Manager and Config Manager as an example, the price is sort of comparable. And then on top of that, you get all the rest of the components in there. And so things like Orchestrator, which are, from a deployment perspective, fairly simple, creating the workflows, and that can get a little complex. But taking advantage of some of these additional tools and technologies really just becomes an implementation thing than a licensing challenge. Just a quick run through, because we'll see most of these during the day. App Controller is one thing actually we won't take a look at. It's a fairly small piece. It's basically a web-based self-service portal for Virtual Machine Manager and Azure. Virtual Machine VMM used to have its own self-service portal. They pulled it out and they kind of bridged the gap so that you can use one portal to create VMs in Azure or create VMs in Virtual Machine Manager. Ops Manager, Operations Manager, has been around since 2005 with MOM. There's been some changes there on the network monitoring and cloud monitoring aspects with management packs for Office 365 and Azure. Service Manager, that's really kind of the service delivery, change management, ITIL, MOF-based tool to really deliver change, incident, problem management, but it also provides the service delivery capabilities through the different service requests. And we'll see a little bit more of that tool in the data center session. Orchestrator, formerly Opalis, is the process automation tool. Really runs in the background, when it's triggered, it'll run whatever task you have specified or whatever runbook you've created. So It can be a runbook to create Active Directory accounts, disable directory accounts, you know, backup databases. You know, an alert gets triggered in Ops Manager, and we know how to fix that alert. You know, it's restarting the service, restarting the server, whatever it might be, restarting an app pool. Orchestrator can do those types of automation sequences. Virtual Machine Manager, from looking at all the different System Center tools, VMM has probably undergone the biggest change. Things like software-defined networks, storage control, private clouds, all really kind of are key to what's changed in Virtual Machine Manager. And again, we'll see some of that. We're not going to get into DPM, or Data Protection Manager. It's their backup recovery tool. It only backs up and recovers Microsoft workloads. So for 99.9% of the organizations out there, it's not going to work for you, because if you've got that one Unix box or that one AS400 or whatever it is sitting in your data center that's running, DPM can't back it up. So we use it here because we are 100% Microsoft. As you start to virtualize those workloads, it does a great job of backing up, Unix and Linux virtual workloads, but it's not a fit for most of the environments that we talked to. We've had a number of discussions with various customers that come in and say, hey, I've owned this DPM thing now. Maybe I'll replace my Tivoli storage manager, or maybe I'll replace my CA backup solution. And the discussion usually ends as soon as we get into, so what non-Windows workloads do you have? And they start listing them off. And we're like, okay, we can't back up any of that stuff. It's usually a conversation killer. And the last bit then is Configuration Manager. We'll see more of that on the desktop side of things, and that's really kind of the desktop management, operating system deployment, patch deployment, application deployment, software inventory, metering, things like that. Now, when we take a look at sort of the private cloud scenario for Microsoft, there's kind of the three key areas here. We take a look at self-service and then the service delivery and automation side of things. Those are kind of the two pillars. And when we take a look at the different pieces that are required, when we get into the service delivery and automation side, that's where we kind of configure and deploy whatever it is we need to configure and deploy, whether it's an operating system, a virtual machine in our public or private cloud. In certain instances in VMM, it could be, Hyper-V hosts, where we can do bare metal deployment of Hyper-V hosts from Virtual Machine Manager. As we sort of circle that back, once those workloads are deployed, monitoring and operating those workloads is sort of the other half of this private cloud solution. And this is kind of where all the different pieces fit into play. It's important to know that this isn't a, insert the System Center 2012 installer disk, right click, new private cloud. It's not quite that simple yet. They do have this, wonderful installer that allows you to say, check, I want to install, all the System Center workloads and click deploy, and it'll automatically install everything. But there's a lot of configuration, and that's not typically the route that organizations go. Our conversations have been around, well, I have Ops Manager and I've got Config Manager. I'd really like to do some service delivery. I'd like to be able to, do application self-service as an example. And we'll take a look at, maybe just moving to Config Manager 2012 and the basic self-service that's built in there, or do we need to go to Service Manager and build out sort of the workflows and policies that go behind that? So not all the components are needed. You wouldn't deploy them all at the same time. It's really kind of a discussion to figure out where you're at, what are your short-term goals and what are your long-term goals, and then figuring out exactly how to take what you have, get it ready, get it upgraded, get it migrated to 2012, and then the next steps to actually build out those processes. We have done 3 projects where it was literally like, hey, here's a rack of servers, here's a whole bunch of money, we want this. And it's 8 to 12 week project and to get to this point. That's really kind of, few and far between those types of projects. It's typically, I've got Config Manager and Ops Manager, we've migrated to 2012. We want to migrate from VMware to Hyper-V. or we want to provide service delivery for applications or HR. We've done a lot of work along those types of process automation side of things. You know, eventually you may get to the point where you have this all deployed. Again, from a licensing perspective, because you have it all, it makes it a little bit easier. But it really kind of comes into, you know, which one of these pillars you're really looking forward, you know, in the short term and what your long-term goals are. So this is going to take us to our first demo. So in this first demo here, we're going to take a look at basically end user scenario for private cloud. So we're going to go into a portal, we're going to request a virtual machine, and we'll see that virtual machine spin up. Very kind of simple and straightforward. And as we go through the day, we'll see how all the different pieces kind of come into play and how this is actually built. So what we're loading up here is the Service Manager Self-Service Portal. And so the Service Manager Self-Service Portal is kind of the Microsoft's kind of key to their private cloud offering for service delivery. This is part of their service delivery tool. So this is your IT, change management, incident management, problem management tool, and also delivering self-service for end users. We've got a number of different requests that are built here. We'll see as we get through the day, you know, there's virtual machine requests, there's incident management that we've got configured. We also have the HR configuration available so that you know, somebody can go in and request a virtual machine or request a new user, or, you know, terminate a user. And so I'll just give you a kind of a quick run through. We got on the side here, we can see there's help articles, my requests, where somebody can go in and actually see the requests that they've made and the activity on those requests. And if they are required to approve specific requests, they'll see those under my activities, where they see any sort of approvals that need to be, any requests that need to be approved. And so through this process here, we can see our virtual machines self-service has gone missing. I guess our Alex, who you'll see in the afternoon, has been working on this, and I think maybe he forgot to check something in. But we'll take you through, you know, again, another offering, and it's really kind of the same offering as you'd see, you know, for anything. The process is the same. All these forms are the same. And what we can see here is there's really kind of a couple of different categories here. We'll see a service offering, which is a collection of request offerings. So here we've got, you know, new hire, termination, vacation requests. Those are request offerings, and we can create as many as we need for the various different types of self-service requests that we'd like to make. And then we can group them into, you know, HR, building maintenance, you know, software self-service, virtual machine self-service, and then based on the permissions that the user has, give them access to certain concepts and certain offerings within that, so that, you know, I don't work in HR, I can't go into the HR portal and give myself a raise, as an example, or you know, or approve my vacation request. Somebody else, you know, needs to take care of that, you know. But I'm a software developer, and I need to be able to go in and request a virtual machine, so I've got access to do that. And we'll take you through this new hire process. It's fairly straightforward. The nice thing about this is we don't need to know SharePoint to actually do this. So this is all running on SharePoint, but you don't need to know SharePoint. You don't have to have any SharePoint development skills in order to do this. This is all done in Service Manager. And so there's a couple of different fields here. You know, there's a list here. You know, this is high priority, and we're going to hire. We're going to hire Brian. I use Brian as an example because he's our latest hire. Brian is in business development, and he is the senior account manager. His phone number is 905 dash, I don't know what his phone number is, but we'll put in a number, and then we can see there's different types of fields here. It needs to be a valid phone number, so if I put in something not valid, it would reject it. We'll see some fields are red. Those are required fields. So we have different types of fields that we can put in place here. And then we can query Active Directory and basically get a list of the different groups that are there and specify which groups he should be a part of. So he needs to be part of the users group. When his account expires, we can put an expiry in place. So this can be for a virtual machine. This could be for an application that a user has requested. In this case here, maybe it's a contract worker, and he's here till Friday, and will expire his account at that point in time. We're going to enable it when it's created. By default, accounts aren't enabled, but we'll automatically enable that. We can attach things, right? So we've got a picture of Brian here somewhere that we could attach. I don't know where. We can attach files. And then who is Brian's direct manager? So in this case here, we'll add that field into the, so it's the user's manager. This person will then get the approval request for this. So we know, is Brian really going to be hired, and is he really working for you? And so the manager of that department can approve that. And we can select multiple approvers if we'd like, but we'll stick with one. Get a quick summary here of what the request is, and I can click submit. And once that is submitted, now there's processes that happen in the background. So at this point here, if I view the request, I can see that the request is in progress, and we're waiting for approval. So at this point here, an email has been sent out to that user's manager or their future manager for approval. Once that approval is given, then the next run book here, or the next activity, will take care of itself, and that's the provisioning of the Active Directory account and the mailbox. So that's we'll see there's, RA is a reviewer activity. Somebody needs to review and approve that. RB is a run book activity. There's manual activities. There's a number of different activity types. And once it's approved, this workflow will kick off, and that's the orchestrator run book. And so we'll get a little bit more into the design of this and how this was built in the afternoon session. But that's basically kind of the process for an end user to make a request. What's happening in the background and how these forms are created is really kind of where the flexibility and where it fits into your organization. Alex has some, I think it's Alex and Jose, one of our two consultants. They both have a lot of experience in delivering these types of projects for various customers, doing a number of different types of self-service requests. But this is kind of showing you the potential of what some of the offerings are. Should I stop or just pause?
You can stop.
How do I? I think I'm just going to pause it next time.
Sure.
What format? Just 1024 by 768?
Yeah, that's
So the other half of this private cloud offering is Windows Server 2012, especially when we get into the virtualization side of things. And there's been a couple of key changes in Windows Server 2012 that really kind of allow, again, from the virtual machine side of things, for some more cloud type scenarios. So one of those on the network side of things, we'll take a look at network cluster storage and Hyper-V specifically. There's been some significant changes. So network virtualization is probably one that you're going to hear a lot of in the next year or so, especially when R2 comes out. Really what it allows you to do is do software-defined networks. So it allows you to have, test, dev, QA, production, all, very much like VLANs, but just in the virtual environment. Really allows you to have those various networks, all using the same IP, subnet, DNS, DHCP, but being able to move machines between those networks without having any issues. So right now, let's say you've got a machine sitting in your test environment and it's running on this VLAN 1 and it has a specific IP and subnet range, and you want to move that from test to dev. Typically dev VLAN will be running on a different IP, different subnet. And so that machine needs to be re-IP'd, and a lot of things may need to be reconfigured within that application because now we've moved it into a different network. And as we move that then into production, or we move that from on-prem into a hosted environment where somebody in that hosted environment is already using that IP and that subnet, network virtualization allows us to separate that network layer, and everybody, instead of using VLANs, everybody can use those same IP and IP ranges and subnets, and machines can move, and as long as there's not a conflict in IP addresses, we don't need to re-IP, re-DNS, re-subnet those machines. That's really kind of the idea behind network virtualization. It's not very well understood. It's not very well documented, which is great for a professional services organization because it's like, yeah, sure, we can do it. It's going to take a long time because nobody knows. Nobody's documented how to do it, but it is something that, as we go forward, especially when we get into these hybrid scenarios with, on-prem and Azure or on-prem and a hoster, where separating that, that physical network layer from the virtual network layer will become a little bit more important. And things like the extensible switch start to make things like that a little bit more possible. So on the VMware side of things, forever you've had the Nexus 1000V virtual switch. Now Hyper-V supports things like that. So there's Cisco has one. There's another one. I can't remember the manufacturer, but they make these virtual switches now that allow you to go beyond just the layer 2 switching that you've traditionally had in your Hyper-V network environment. And a nice one, for the more technical people, in the room here. NIC teaming is now built in box. So I don't need to have, all the same, Broadcom or Intel network adapters with the specific driver that supports NIC teaming with the little applet that they have running that allows you to create that NIC team. And if you're trying to do that in a server core environment where you have to do it all by command line, and Intel and Broadcom and they all have different command line environments for that, making it difficult to automate. With NIC teaming built in box, it can be all controlled via PowerShell. It's all the same across Windows. It doesn't matter what NICs you have in there. And you can use a combination of manufacturers and even a NIC type. So you can take, you can build a failover, a failover NIC team using a 1 gig Intel NIC and a 100 meg Broadcom NIC, and specify that the 1 gig NIC is your sort of main one and the 100 meg is your failover. There's a number of different combinations that you can do there, which is quite nice, something that you haven't been able to do before. Really, from the automation perspective, though, that's where we can now say build that run book to spin up that physical server, deploy the operating system, do the complete configuration, and add it to our server, and using PowerShell to do it all. One thing to note, I think in 2008 R2, there's around 250 to 300 PowerShell commands built in. There's almost 3,000 PowerShell commands built into Server 2012. there isn't anything that you can do in the GUI that you can't do via PowerShell. Absolutely everything can be done via PowerShell. So that is, you know, Microsoft's been kind of going down that route for a number of years now, and they just keep moving in that direction. On the storage side of things, SMB v3, if you've got Windows 8 clients and Windows Server 2012 file servers, you'll see some pretty significant data transfer speed increases. But more importantly, on the server side of things, this really allows you to take advantage of things like storage spaces and what they call scale out file servers, where you can now run virtual machines from a file server. So the VHD files can sit on a file server. Hyper-V can access those over SMB v3 and get near iSCSI fiber channel performance. You can actually exceed fiber channel and iSCSI performance in certain types of environments with, you know, some of the specialized RDMA network adapters and, you know, 10 gig network and network teaming and all those things. You can actually get to a point where for significantly less than what you would spend on like a 10 gig iSCSI, you can do the same thing with their storage spaces and scale out file services via SMB3. On the cluster side of things, two kind of key changes: cluster aware updates and dynamic quorum. We'll look at those a little bit more in just a second, but really kind of improving the resiliency of Windows clusters, both Hyper-V and non-Hyper-V clusters, your traditional clustered workloads. And then on the Hyper-V side of things, some VM enhancements, what they call, I can't remember what they call it now. It's a new virtual machine type. Right now, if you build a virtual machine, you've got this mix of what they call legacy components and virtualized components, where legacy components are emulating specific pieces of hardware. This new virtual machine type eliminates all the legacy components. All the virtual hardware components are all virtualized, and you get much better performance again, near physical server performance. It was pretty close if you're using virtualized hardware with the existing VMs. You'd have to get into some very deep monitoring to see any sort of performance difference between a physical machine and this non-legacy next generation virtual machine. And then on the live migration replication side of things, there's been some significant enhancements. And then key to all this again is the management and automation coming together with System Center. Scale enhancements. You know, some of these look great, 4 times the number of virtual machines in a cluster. Well, it's because we have 4 times the number of nodes that are supported in a cluster. So if a 16 node supports 1,000 virtual machines, a 64 node cluster can support 4,000. So that's where some of that scale comes into play, is just more nodes in a cluster. On the host side of things, you know, the Windows Server supports more processors. So we've got the ability to support more logical processors on the host, which means we've got support for more processors in the virtual environment. Memory, you know, now it supports up to 4 terabytes, whereas the previous iteration only supported 1. So that gives us more memory for virtual machines. So we've got larger workloads that we can run in this environment. A lot of this just comes down to what they can test. When 2008 R2 was being released, I got to go and see one of these test centers that they had at Microsoft, and they had these memory modules that they would rent from IBM. And they would, you know, at the time, you know, to get a terabyte of memory, I mean, to get a terabyte of memory today isn't that difficult. It might be expensive, but you can go to HP, you can go to IBM, you can go to Dell, and you can say, hey, I need a server that's a terabyte of memory, and they'll sell it to you. It's not hard to get. In 2007, 2008, when they were doing their testing for these versions, you know, they'd rent these memory modules from IBM for like a month, so that they could do their testing of the operating system, and they could rent a terabyte, and that's all they could rent. So they'd say, okay, we support it up to a terabyte of memory. There was well, there was a limitation. It wouldn't support more than that, but it was just a cap put in place because they couldn't test beyond that. Same thing with, you know, logical processors. You know, an 8-core, 8 CPU machine back then was wow, that's pretty rare. Now, again, HP, Dell, IBM, they all have them off the shelf. You can buy them. They're expensive, but you can get them easily. And so a lot of this is just, hey, now we can rent 4 terabyte modules from IBM, and we can throw in, we've got 10 10 core CPUs, and we can throw a lot of more CPUs into a physical box. And so a lot of these changes, because we have support for more memory, more CPUs, we've got more capabilities in what we can run. And again, this really just comes down to some of those workloads that we wanted to run in a virtual environment, but might not have fit in a virtual environment because they had more than 64 gigs of RAM, or more than 4 gigs of RAM, or needed more than 4 virtual CPUs. Some of those larger SQL workloads where it'd be nice to, but I'm consuming all the resources in my host machine running one virtual machine, so it doesn't really make sense. We can now run those in that type of environment, and we've got some virtual machines that we run here that are 32 gigs of RAM and 4 cores, and since going into Windows Server 2012 for what we run, we've been able to increase performance by, the hardware was there, we just weren't able to provide it to the virtual machines, and now we can. And so a lot of those workloads where, I remember, a long time ago, VMware said, yeah, virtualize everything, when it really didn't make sense to take that SQL server that was 4 cores and 64 gigs of RAM and like I said, consume 50% or 75% of the resources on the host just to run one virtual machine. Now we can, and we can do further consolidation, where, as Brian was mentioning, years ago, 5 to 1, 6 to 1 consolidation ratio was pretty good. Now we can get, 10, 20, 30 to 1 virtual machine ratios on some of this, on some of these workloads. One thing to note here too is there is a virtual disk size of 64 terabytes. That's one of the new things in Hyper-V 2012. That's a VHDX file format. So it's an expanded file format that supports up to 64 terabytes, but it only supports Windows 2012 and Windows 8 virtual machines. So you can't, if you needed a 64 terabyte VHD, you need to be running Windows Server 2012 to support that, or Windows 8, because each desktop doesn't need 64 terabytes of storage. So Nick Teaming, as I mentioned, allowing us to build a team of network adapters using built-in network adapters, sort of whatever variety. So this environment that we're going to be demoing in the afternoon is two Hyper-V servers. And there's a mix of like Broadcom and the Broadcom onboard NICs with some 4-port Intel NICs that we had laying around that we plugged in. So it's a mix of network adapters. We've got a mix of different teams in there. Load balanced with failover. It's just to kind of support the demo environment. The extensible switch then, we don't have that running in this environment because we actually don't need it. It's a 2-server environment, and everything's directly connected. But this really allows you to expand on top of that with virtual NICs and virtual NICs within VMs, and really kind of bringing that next level of network virtualization, which allows then in the future that software-defined networking or network virtualization. And this is kind of the concept here, where we've got a number of Hyper-V hosts. We've got a dev network, a production network, maybe it's an on-prem network and a hosted network. They're both using the same IP and DNS range. And as machines move around, if we end up with 2 machines with the same IP, same subnet running on the same host, we're not going to see any conflicts there because those networks are virtually separated or logically separated in that environment. And again, as we move those virtual machines into Azure, we move them into a hosted environment. We don't need to work on things. And this, from a hoster perspective, this is kind of where we'll see the first sort of adoption, because for them it's great, right? Because there's nothing worse than a customer saying, hey, I want to move my workload into your environment, and saying, sorry, that IP range is taken, you're going to need to re-IP everything, which in a lot of instances might lead to applications having to be updated, somebody having to rewrite code because software developers love to hard code things into their applications because it's guaranteed to work rather than using this thing that we have called DNS. It's just one of those challenges, especially when we have legacy applications where we may not have anybody to rewrite or recode that application, and so it can be a real challenge in those types of environments. Storage spaces. If you're not familiar with storage spaces, what this is, it's a feature in 2012 that allows you to basically create virtualized storage using standard Windows hardware. So you can take that Windows server that's sitting there that's got a mix of disks, throw whatever disks you have left over in there, and build virtualized storage. It can be a mix of different types of disks different sizes, different speeds, different SATA, SAS, SCSI type disks, and really build what you would have, in a sort of from a NetApp type of SAN experience where you've got the ability to hot add and hot spare disks, have parity, have mirroring, and provide that type of storage virtualization for file services, for Hyper-V, and even for things like failover clustering. We can, if we're not using the new RDMA NICs, or we don't have a full Windows Server 2012 environment where we can take advantage of SMB version 3, and there's also built-in iSCSI targets, so you can build your own storage for providing those types of services. And so again, dev, test, QA type of environments where we don't necessarily want to go out and spend $20,000, $30,000, $40,000 on a SAN, but we have this box that's sitting there that's doing nothing, and we can go out and buy a bunch of cheap disks and throw it in there, or maybe attach JBOD and provide those same type of storage services that you would get out of that expensive SAN at a much reduced cost, again, for those test dev environments. Eventually we may see this move into that production type scenario where you would use storage spaces for for providing the back-end storage for your Hyper-V or your file server clusters. We will see NetApp and EMC and those companies come out with storage-based supported SANs and also supporting SMBv3 in their SANs. So if you're not using iSCSI or Fiber Channel, you can take advantage of those technologies as well. Cluster-aware updating. This is something that you could actually do even with Virtual Machine Manager 2012, the initial release, in your Hyper-V environment, where you basically create a baseline and a new update comes for that base for Hyper-V as an example. Excuse me, and you just basically add that to your baseline. When the maintenance window comes into play, Virtual Machine Manager will migrate all the virtual machines running on that particular node of the cluster off, put it into maintenance mode, do its update cycle, reboot, whatever needs to be done, bring it back online, and then migrate the virtual machines over. So you can do that with VMM in a Hyper-V environment. And now in Windows Server 2012, we actually brought this into play for just standard Windows clusters. So you may have a SQL cluster, you may have a file server cluster, and there are some Windows operating system updates. So not SQL updates, but Windows operating system updates where we can say, hey, you know what? We got our 3-node SQL cluster here. There's some critical Windows updates that need to be applied to the host, and we can just target that. And what'll happen is, we'll fail over those resources from node 1 to the other nodes in the cluster, put that node into maintenance mode, and apply those updates, restart the services, kind of go through that process of getting that machine updated. And once it's updated, fail the resources back and repeat on node 2, and kind of go through that process of updating the nodes in the cluster without, again, any sort of manual intervention. I mean, right now it's a process where I gotta go in and I gotta manually move things over. I know our infrastructure guardian, our managed service, they do this for customers, and they have to go in and migrate those workloads over, patch the system manually, go through that process, and when it's back up and running, fail those resources back and repeat on the second node and going through the cluster and doing that. And so it's nice to be able to just target that cluster with an update and let Windows do the automation. Right now, again, it is just for those core OS updates. So if there's SQL updates that need to be done, that's still sort of the manual process. But as we see, next generation of SQL come out, I'm sure we'll see some of those things come into play there. Now, dynamic quorum is something that kind of a small change, but really allows you to do a number of fairly significant things on the private cloud side of things. And especially, when we talk about green IT, Brian mentioned that, nobody's shutting down that server because, they don't need it anymore. But there are some instances where in a virtualized environment, you may want to do that. And dynamic quorum sort of extends that and really allows that to happen. Right now, with Windows Server 2008, you build an 8-node cluster. You can lose 4 nodes of that cluster, and everything will run fine. When you lose the 5th node of that cluster, the cluster will fail. Even though you've got 3 nodes still up and running, and you can build a 3-node cluster, Windows doesn't see it that way. It just sees it when you build that cluster and when you add nodes to that cluster, it calculates quorum and it says, okay, we can lose this many nodes. And if you lose one more than that, everything goes to hell. Even though you may still have a number of resources available to provide that service. I mean, in fact, you can build a 1-node cluster. It's not really highly available or anything, but you can do it. And so as you lose nodes in the cluster, technically you could still have 1 node running and your cluster would be healthy. Windows 2008 would just not see that. It would, it calculates quorum, and as soon as it gets below that number, things fail. With dynamic quorum, what happens is as you lose nodes, it will recalculate quorum. So, when I have a 5-node cluster, I need 3 nodes for quorum, so for my cluster to be healthy. So I lose a node, and I've got a 4-node cluster. Fine, we still need 3. But as I continue to lose nodes, quorum will change. So now I've lost 2 nodes and I only have 3 remaining. It will recalculate quorum and say, okay, well now I need 2. And as we kind of continue to lose nodes, it will recalculate quorum until the point where, if you lose all 5 nodes, well, I mean, you've got bigger problems. But we can continue to lose nodes and it will recalculate that. And so from a highly available perspective, it's one thing to be able to, sustain multiple node failures and still have your cluster up and running. But when we get into those types of scenarios where, with VMM and dynamic resource optimization and power optimization, where we can monitor, the workload on those Hyper-V hosts, and Monday to Friday, 9 to 5, everything's running full tilt. All hosts in that cluster are up and running, and machines are spread across all 16 nodes in the cluster for maximum performance. But as soon as Friday 5 o'clock hits and everybody goes home, utilization goes down. VMM can consolidate those virtual machines, keep them all running, but run them on fewer hosts in the cluster because their performance and their resource requirements aren't as high, and then actually shut down or put to sleep the additional nodes in the cluster. We couldn't really do that. You could do it in 2008 R2, but you had to be careful because if you shut down too many nodes for power saving and then lost the node, your cluster would fail. It wouldn't be smart enough to start up an additional host in that cluster. And so you have to be really careful with that power management within VMM. Now, the fact that we can dynamically recalculate quorum as those nodes shut down and as they start back up again really allows us to take advantage of some of those features. So there's only 2 requirements. You have to have a cluster in the first place. You need to build that cluster and have it go through its validation and come online. And then you need to lose nodes sort of in sequence. If you lose multiple nodes at once, if you lose 3 or 4 nodes at once and there's enough time between the next node failure and it has time to recalculate that, it's okay. But if you were to lose 4 or 5 nodes at once, it would fail. One other thing with clustering in 2012 is previous to 2012, you need to have a physical domain controller, because that domain controller needed to be online and available, because when the cluster came online, it needed to verify itself in Active Directory. Now it can actually start up without having access to Active Directory. So virtualizing domain controllers again becomes more of a capability and a feature set, because we don't need access to Active Directory when that cluster starts up, as long as, 15, 20, 30 minutes after that cluster starts, it gets access to Active Directory. Everything is okay. Virtual machine migrations, we're all sort of familiar with live migration. That hasn't changed in a cluster type scenario. Live migration, vMotion for the VMware people. Just really allows you to take a virtual machine that's running on one node of the cluster and move it to another node of the cluster without any downtime. It's a planned failover type scenario where I need to do maintenance, and I'll just take this machine and I'll move it from node 1 to node 2. And from a user perspective, they wouldn't know, and everything is functional. In fact, if you're pinging a machine during live migration, you may drop one ping, maybe. Typically what you'd see is the TTL kind of go up above 100, 200 milliseconds, but you usually don't lose any pings. Storage migration has been enhanced in VMM 2012. Prior to that, you could do what they call a quick migration. In a quick migration, the virtual machine would be paused, the VHD would be transferred to the new storage array, and then the machine would be restarted, or resumed, not restarted. So basically putting the VM to sleep. Fine for most scenarios, but what you'd have in that, is if you had a very large VHD file, 256 gig VHD file, and you're copying it over a 1 gig network from one SAN to another, that quick migration might not be so quick. It might be 15, 20 minutes. So the definition of quick varied depending on your expectations, your network speed, and the size of the virtual machine. Storage migration in 2012 is now what they would call live migration. And the virtual machine will stay running, and basically what happens is, much like in a live migration where we take a snapshot of the memory, copy that over to the new host, and then do a synchronization of the memory between the two, and then once the memory is synchronized and we have the virtual machine running in both nodes of the cluster, just fail over the resource. Storage migration is the same thing. We'll take a VSS snapshot, copy that over to the new storage array or new storage provider, and then do a synchronization of that storage. And once that synchronization happens, we have an exact same copy of storage on both storage systems, then we'll switch the connection from the VM over. And again, there's no downtime. If we were pinging that machine, if we were doing a file transfer, it was a file server, and we were doing a file transfer, there'd be no interruption to that. And probably the biggest change is this concept of shared nothing migration. So in a live migration type scenario, we need a cluster, which means we need shared storage. Shared nothing migration is a mix of live migration and storage migration, where we're going to synchronize the memory and we're going to synchronize the storage and move that machine from one host to another host, non-clustered, and move that machine again in a live type scenario. It's not what you would call a failover scenario. So in a live migration, in a cluster type environment, if one node fails, that virtual machine will restart on the other node automatically. In a shared nothing type scenario, if the host fails, the virtual machines aren't going to restart anywhere. You'll need to copy those files over and start up those machines manually. But this does allow you to, again, move a machine from maybe a single standalone test dev Hyper-V box into your production Hyper-V server. It also allows you to do migrations from one cluster to another cluster, especially when we're going from 2008 R2 to 2012, or from 2012 to R2 or future versions down the road. This allows us then to take that, while we've run out of capacity on this cluster, hey, we've built this brand new cluster, and do a shared nothing migration across the board. So that's quite nice in that regard as well. The last piece here is VM replication. Again, for the VMware people, this is what VMware will call fault tolerant or fault tolerance, which is a feature that you can add on to your VMware subscription. This is built-in box and basically allows you to replicate from a Hyper-V server or a cluster to another Hyper-V server. So from one node in a cluster or from one Hyper-V host, we can replicate that virtual machine to another host and have it available there. So if the host fails, I can go over and I can restart it on the replica server. And so this, this is a lot. Works very much like log shipping in SQL, where it'll collect all the changes that are happening to that virtual machine and synchronize it every. I think the default is 15 minutes, but you can adjust that anywhere from 5 minutes up to however long you want it to be, depending on the workload. And it'll replicate all those changes that it captures over to the new node. Basically, it's taking a snapshot and then copying that snapshot to the replica server. So the initial seeding may take a while. You can just do a copy and paste manually and say, hey, this is the VHD that I'm using, and then just synchronize the snapshots. But once that's working, we've got every 15 minutes the snapshot being replicated over. And if something happens to the node or to the entire cluster in this regard, we'll fail over the machine to the replica server. This is somewhat of a manual process. The virtual machine won't automatically start up on the replica side of things because one of the other configuration options that we have is the ability to, with all these snapshots being sent over, we can save a number of snapshots. So let's say on the production side of things, we apply a hotfix, and the hotfix blue screens the machine. I can bring up the replica and I can go back in time to the previous snapshot before I applied that hotfix and bring that one up online to get the machine up and running, and then go through the process of repairing whatever happened on the other side of things. And so, so it's a manual process. You can automate it with PowerShell and Orchestrator. But one of the other things that happens in that type of scenario too is you can actually automatically re-IP the machine. So you can have failover IP settings if you'd like as well. This here is kind of key to that scenario that Brian was talking about earlier, Hyper-V Recovery Manager with Azure. It actually uses Hyper-V Replica. So you've got Hyper-V and VMM in your production data center. You've got Hyper-V and VMM in your DR data center. And you're using VM replication to replicate the virtual machines from production to DR. And then there's a provider that gets installed in Virtual Machine Manager that reports into Azure. And that's where you build your failover sequences. So within Azure, you can click that button and bring all these machines online and do all the IP automatically. But you need the Azure service for that. Right now, it's not an automatic process, although you could, like I said, build it with Orchestrator. As much as the consultants here hate it when I say this, you can pretty much do anything with Orchestrator. It's especially as we get into the 2012 suite of things and everything can be done with PowerShell. They don't like it when I say, yeah, you can do that. But in reality, you can. It really comes down to the time and effort that you want to put into it. Once that machine is up and running on the replica side of things, and you bring up the original side, the side that failed, it will synchronize back. And so once it's synchronized back, you could then bring that replica back up online on your production server and have your replica server just being that replica server again. One thing this doesn't protect from is those, it's really meant to protect from hardware failure. So if a machine blue screens and you bring up that exact same snapshot that blue screened, well, that snapshot's going to blue screen as well because it's within that same memory block. But it does allow you to go back in time to before that happened, a previous snapshot, maybe before the application was updated or a hotfix was applied, and bring that online. A couple things with this. I'm just going to bring up all these things here. From a storage perspective, it doesn't matter. There is no issues with storage. So if your production cluster is running, shared storage with SAS disks and fiber channel connectivity and all that fancy stuff, and your replica server just has a direct attached SCSI disk, maybe it's running RAID 1, doesn't matter. It doesn't matter what operating system is running within that virtual machine, because it's just taking snapshots and sending those across, so it's doing it at the host level. So whatever's going on inside that virtual machine can be running Windows 2000, can be running NT, can be running Unix or Linux. We can do the replication. Replication is unlimited to the extent of the hardware that it's running on and your network connectivity. So if you've got very, very busy virtual machines and you're taking snapshots every 5 minutes and you've got very large snapshots to replicate and you're doing it over a very small connection, you're going to be limited by that. But the more storage, the faster storage subsystem, the faster the network between those hosts is, and the amount of storage that you have on both sides, it's really kind of unlimited. One of the challenges with fault tolerance from VMware is you're kind of limited to 4 VMs per host that you can replicate, and there's some challenges around that. But from a VM replication piece in Hyper-V, it's really limited to the hardware and the resources that you can give it. It's also geo-independent, so you can replicate from anywhere to anywhere. It doesn't really matter where those data centers are. You need as long as you've got a direct, site-to-site type of VPN connectivity, we can replicate over that network. Cost-wise, licensing on the host side, you need to have licenses on the host side, but because the virtual machines are not running on that replica host, we don't actually need a license for those virtual machines because they're not running. So Microsoft's virtual machine licensing, you only pay for the licenses for the virtual machines that are running. If you are using, and in this case you need Windows Server 2012, there's 2 versions. There's Standard and Data Center. Standard you would use for a single workload like a SCOM server or a config manager server. If you're doing anything virtual, the recommendation and the best practice is to use Data Center, and then you don't need to worry about virtual machine licenses anyways, just the host licenses. Obviously, storage on the destination side is a cost, and the bandwidth between those sites is a cost as well, and how often you're replicating. Getting into R2, you can actually change that replication interval down to like 30 seconds or something like that to get sort of near-time replication. That's just going to increase bandwidth costs because we're going to be replicating more often. But in certain instances, it might be something that you want to do. The other thing is this is these configurations are a VM by VM configuration. So I may have a file server that changes very infrequently. It's archive server, and maybe I want to take a snapshot once a week and replicate that over, versus a domain controller or a SQL server or something like that, where I want replication to happen at a faster process. It's independent across the board for each VM, so that's nice. So that takes us into the public cloud side of things. Public cloud things get a little easier to understand because we're really kind of replicating a lot of services that we're already familiar with. So in this scenario, we're going to basically, in the public cloud services perspective, we're going to take a look at Azure, Microsoft's public cloud service. Give you a quick run through. I don't know how many people are familiar with Azure. A quick run through the different offerings just from end to end, the different services that they've got available. And then take a look at virtual machine creation, network creation, and sort of building out that virtual data center in their public cloud service. The next demo will actually look at sort of tying in those services through the hybrid connectivity. So if you have an MSDN subscription, you get a certain number of what they call credits. So you basically get enough credits to run, I think it's like $150 a month in credits, which depending on the services that you're running, that's what they would call as 3 small VMs, 1 extra large VM. There's a calculator. If you go into the portal, there's a pricing calculator which will kind of explain you know, what the costs are, and it's a nice little, you know, if I go into virtual machines here, I'm going to need extra small is 1 gigahertz CPU with 768 megs of RAM, and as we go up, it just doubles the resources. So small is twice of what extra small is. So that's 1.6 gigahertz with 1.75 gigs of RAM. Medium is 2 CPUs with 3.5 gigs of RAM. Large is 4 with 7 gigs, etc., all the way up to their A7 virtual machine, which is 8 core with 56 gigs of RAM. And then you can specify, you know, how many VMs you'd like. So I want 3 small VMs, it's $267, or 4 small VMs, $267 per month. That's sort of their, you know, suggested retail price. You're never going to pay more than this. It'd be hard to find a place that'll sell you more than this. But if you sign in for 6 months, you prepay, you know, longer sort of contracts you sign, the price comes down. And you can also sort of roll this into enterprise agreements. So you may have some of this as part of your EA. And there's also, if you don't have MSDN, you can get a free trial. And the free trial will give you like the ability to run basically 1 small VM per month for free. You know, a couple of some of the other services, maybe a website, maybe, you know, a certain amount of storage. But the calculator really kind of helps you figure out, you know, what it is that, what it's going to cost you, and give you kind of an understanding of what it'll cost. When you log into the portal, you know, this is what you'll see. This is it. It's a brand new portal. I just logged in. There's a couple different things from a getting started perspective. Websites, basically anything IIS related. You know, anything that you would run on IIS on-prem can be moved into Azure. It'll do PHP, it'll do Java, it'll do you know, all the different various web languages you can run within Azure. And you basically get charged by the amount of storage you take up, the amount of time that application is running. And when they talk about network and data transfer, it's always outbound. So you can upload as much as you want and you won't pay a dime. But as you start downloading that, and as people start accessing your website or doing RDP connections to your virtual machines or downloading documents from those websites, that's when you start paying for data transfer costs. Virtual machines is virtual machines. You know, this is what we'll take a look at in a moment. This is running a VM like you would run it on Hyper-V, but running it in Azure. Mobile services, this is actually in preview mode. This allows you to provide you know, mobile services, so mobile applications, those types of resources. Cloud services is sort of a combination of different things. So we can see here we've got compute, which is basically raw CPU power, data services, application services, networking. There's a store that has some sort of predefined cloud service. So cloud service would be something like an application that has various components. So WordPress, you know, WordPress is a database backend, the web front end, and then obviously there's some networking that goes on between those two services. That's kind of a cloud service. You've got SQL storage or SQL database and SQL reporting. We could put SQL reporting in the cloud tied to our on-prem SQL and use this just for providing reporting services. Storage is basic storage. You know, there's a number of services that tie into this, so we'll create a storage account when we create our virtual machines, because that's where our VHD files will sit. But there's also a company that, again, Microsoft just bought called Simple Store. It's an on-prem device that has, you know, X number of terabytes of local storage, and it has the ability to identify, you know, hot versus cold data and take that data that's being accessed frequently and store it on-prem in its local storage. But also then take all that cold data that doesn't get accessed very often and push it to the cloud and use the cheaper storage of Windows Azure to provide, you know, the storage for that back end. Things like DPM and Windows Server 2012 also allow you to back up directly to Azure. So when you go into Windows Server Backup in Server 2012 and you create a backup job, you can back that up directly to a storage account in Windows Azure. As opposed to having, you know, some sort of storage device on-prem for that. Media services, streaming media. Service bus, this is an application, custom application layer thing, so we can have basically a communication channel between various tiers of the application. Active Directory for extending your on-prem AD into the cloud to provide single sign-on for applications in the cloud. It's also used for Office 365. You wouldn't see it here, but Office 365 in the background is using Azure Active Directory. Networks, basically your networking. Add-ons are other things you may purchase for your Azure services to take advantage of. So one of the add-ons is the Bing Maps API. So you create a web service that requires access to Bing Maps. You buy the add-on here, and then you'd be able to tie your application into Bing Maps, as an example. And then settings is just your basic settings, management certificates and administrators and things like that.
Well, would the Azure Active Directory service also provide functionality for certain businesses that, say, you have a company that often goes through M&A, so they could very well have multiple directories, multiple forests. Does it have a virtual directory component to help bring those together while the company does its own integration?
Sort of. So this is Active Directory as we know it in the cloud. But it's really meant to provide authentication to your other cloud-based services, right? So as an example, Office 365, right? When you use Office 365 for enterprise, you synchronize your on-prem Active Directory with Office 365, which is Azure, really in the background, so that I can go into the Office 365 portal and use my rodney@cms.ca email address, and it has all my credentials there, so it can do that authentication. But it's not meant to well, hey, I'm going to take my Active Directory, I'm going to stick it here for now, do all this migration acquisition stuff, and then move it back. It's not meant for that. It's meant so that here I can provide, I build a website, right? I got a web service that I provide, a line of business application for my enterprise, and they need to be able to authenticate to that with using their AD credentials.
Okay, so it kind of helps with that single sign-on.
Yeah.
We used it for, it came back to Office 65 requires access, obviously, your Active Directory. We need, so that means it's still relying on your internal infrastructure, so you still have high availability, it needs to be always on. So having an Azure means now I don't need to invest capital expenses.
Yeah.
Maintenance beyond on-prem equipment. It's now really fully in the cloud, not just all in the cloud, but sort of relying on your infrastructure.
Yeah.
So that was a really good one.
Yeah. And yeah, there's a tool at Microsoft called DirSync, which takes your on-prem Active Directory and just synchronizes up to Azure for things like Office 365 and for your web services and things like that. You can create a virtual machine and use that. Put a DC, like a physical domain controller, in as a virtual machine and do those types of things, right? But it's just instead of having it on a Hyper-V host on-prem, you have it in a Azure VM in the cloud. So I'm going to go in and I'm going to create a virtual machine here. I can go through basically two options here. I can go into the gallery, and there's a number of different types of pre-configured virtual machines. I can build my own sysprep VHD file and upload it into my disks and have my own sort of corporate gold image there, or corporate gold disk. And then my image is again, here we've got, there's going to be some configuration with that, CPU, memory, those types of configuration. I can build those images, much like you'd see with like a VM template in Virtual Machine Manager. So I'll just take Server 2012 Data Center, click Next. This is the release date, virtual machine name, just CMMS3, it'll be a small VM, username. So one thing you'll see here, it's not going to let me use administrator. We'll see from a security perspective a couple things here. It's not going to let you use very common usernames like administrator, because these machines are online. They're publicly accessible as soon as you bring them online. And lesson learned the hard way from a colleague at Microsoft is when you have this machine running up there using a, the default secure password for Microsoft demos is p@ssw0rd. With administrator, what they found is that, internally they would use those for their demo machines. They'd have them running in Azure, and they'd get compromised pretty quickly because they're online and they're public and people are doing port scans and hammering away with, common username and password combinations, and those machines are getting owned pretty quickly. So they decided to say, no common names, and if I were to try that, p@ss password, it wouldn't allow me, so I have to create a similar, see, password is too common, so I can't use that. So now I have to use a real password, which I have to try and remember, so I'm going to use my real corporate password because I should remember that one. So it's quite funny hearing some of the things that people were doing with Microsoft demo VMs in the cloud and all sorts of interesting things that they learned along the way. So username, I should remember that. It's my username and my password. Two options here: standalone virtual machine, connect to an existing virtual machine. Connect to an existing virtual machine allows you to build basically an NLB cluster. So if we were building a sort of a front-end web farm, I would build the initial standalone virtual machine, and then the next virtual machines I would say connect to an existing virtual machine and specify that virtual machine, and Azure will then configure the NLB configuration for those virtual machines, allowing you to build out that NLB cluster. DNS name, one thing to note here, this is a unique name. Oh, it's actually July 3rd. This is a unique name, not within your Azure account, but across Azure globally. Because this is a public, this is the public DNS name. You'll see here it's given the cloudapp.net DNS name. It needs to be unique globally because once this is created, I can go to cmms3july3rd.cloudapp.net and access this server. So if it wasn't unique, then obviously we'd have conflicts with multiple machines having the same same DNS name. So that's one thing to note. I don't know how often they purge their DNS, so that if I'm using CMMS July 3rd and next year on July 3rd try and do the same demo with the same virtual machine, if that would work. I don't know how often that gets purged, but that's something to note. Storage account, because this is a brand new Azure account, it's going to automatically create the storage account as part of my Azure subscription. It doesn't cost anything to create these accounts. You're only paying for the amount of storage space that you use. And as part of the virtual machines you get, as part of your trial, you get a certain amount of storage. So I'll leave that to create its own storage account. And then I already have an affinity group created. What an affinity group is, if you think of an Azure data center, it's a large warehouse, and within that warehouse they have basically shipping containers, and those shipping containers have racks and racks and racks of servers, and they're all sort of interconnected. And so within the data center, or within the warehouse, they may have 100 of these shipping containers, and within the shipping container they may have 100 servers running virtualized workloads. And when it creates a virtual machine, it's just going to create it on, by resource levels and what it is that you're requesting. It's just going to create it somewhere within that data center. There are 8 data centers: Eastern Asia, Southeast Asia, North Europe, West Europe. There is Central US, and then there's 2 in the Eastern, 2 in the Western US. Actually, I think that's 9 data centers. And so you can select the data center. When you create an affinity group, you can basically select the data center. So, because we're in Toronto, we're closer to the Eastern US data center. So even though there's 2, you just select Eastern US, and it actually replicates between those two data centers. So one data center fails, your resources come online in the second data center. So that's kind of a high availability thing. So it allows me to pick the closest data center geographically, but also then with an affinity group, what it allows me to do is then within that data center and all these containers and all these racks of servers in that data center, I can create an affinity group, and everything that I create within that affinity group is at least in the same container, more likely in the same rack. So that if I'm building, you know, a front end back end, let's say I'm doing a SharePoint deployment in Azure, I don't have my web front end sitting in this container on one end of the warehouse, and my database back end sitting on the other end of the warehouse in another container, because there may be some latency issues between that. Everything will be in the same container, at least, typically in the same rack, so that network latency issues aren't an issue. And again, we can create multiple affinity groups and go for availability set. You know, I can create an availability set. This is more similar to a traditional cluster in some ways, in that with an availability set, I would have a replica of this not in another Eastern US data center, but in another data center somewhere in the globe, so that if, you know, the entire east coast of the US goes away for some reason, that I can bring up my resources, or my resources will come online in one of the other geographic regions. Also allows me to, you know, if I am, you know, sort of global company and I want everybody around the world to have access to the closest data center, I can have availability set and have that resource running in all those different data centers, and then based on, you know, geographic location, I get access to the closest one. Enable PowerShell remoting. We want that enabled so that I can run PowerShell commands from my notebook against this virtual machine. And we'll click complete. We'll let this go. I'm not going to sit here and watch this. It takes a few minutes for this to take place. But we'll come back to this in sort of the second half of the demo and take a look at the completed virtual machine and some post build configuration that we're going to do. And so when we take a look at virtual machines specifically, we kind of covered off. We can create images from the pre-built gallery. We can build our own images, which will specify, much like a VM template, you know, what affinity group the machine is going to be deployed to, what virtual networks it's connected to, is it an extra small or is it an extra large VM, what OS, you know, what VHD from our VM depot are we going to select, so that again, from a, you know, a deployment perspective, I just have my own images there ready to go, much like you see in the image gallery. The VM depot is kind of the most basic of that, where I've got a sysprep VHD file that I built on Hyper-V, and I just upload that into Azure, and every time I build the VM, I can say, you know, use that as the base VM. It'll make a copy of that in Azure and go through that mini setup wizard. That's all going to be based and all sits outside of the image gallery. My images and VM depot sits in your Azure storage account, and as you deploy VMs, they get dropped into a Hyper-V host running in Windows Azure. And then the affinity group, you know, we'll have them all within that, sort of in its own same network. Just kind of going through the process again of taking a VHD file, uploading it as an image, or creating a virtual machine and making an image of that. I think a better term for that would be a template of the virtual machine that you want to deploy, and then taking those images or those VHD files and creating virtual machines. Now with storage, the way Azure works from a storage perspective, and this is storage for your VHD files, this is storage for just things that you upload, is always replicated. So in Eastern US, Western US, even though it's, those are bad examples. So in the Eastern US, there's 2 data centers, but those 2 data centers is really actually 4 data centers. So there'll be 2 data centers within 100 miles of each other, and then another 2 data centers within 100 miles of each other. And storage is replicated between data centers that are at least 100 miles apart. So even if something happens to the data center, in fact, it's actually replicated to 3 data centers. You only pay the 1 storage cost, even though it's taking up 3 times the amount of space because it's replicated to multiple data centers. But just from a data resiliency and you know, if something happens to the data center, that you still have access to your data, it's replicated across a number of data centers. And basically your storage subscription in Azure speak, that's a container, and within that container you've got what they call blobs of storage, and that's just the way it's sort of divvied up in Azure. What you would see from your storage device or from your Azure account is it all looks like, well, here are all my VHD files, and that's kind of a blob, and then my SQL storage, my SQL data would be stored in another blob. And I can create these within Azure and sort of segment my data and say, okay, well, here's my VHD file, here's my store simple cold data, here's my SQL data. And then all that is replicated from between data centers for availability. You can actually pay for additional replication to replicate this geographically kind of around the world. Virtual networks, by default, when you create that virtual machine, it sits on an Azure network that they have. It's a public network that gets a public IP address, public gateway address, and public DNS. So when I log into that virtual machine for the first time, I've got full outbound web connectivity, and I've got full inbound web connectivity. They have some endpoint protection in there, you know, blocking what happens coming in. But that machine comes online and it's on the internet. Fairly straightforward. I can extend that, as we'll see in the next demo, on-prem. And so in this case here, what I'm going to do is I'm going to build my own virtual network, and I can subnet that virtual network, and I can provide my own gateway network, and then tie that gateway network into my on-prem router and have that hybrid connectivity, so that those virtual machines that I have running within Azure can actually join our on-prem Active Directory. Typical scenarios that we see for this, you know, as Brian was mentioning earlier, kind of test dev and moving test dev up there. We've talked to a number of customers about, you know, again, this Office 365 scenario, as John was saying there, you know, it still comes back to your on-prem Active Directory. So with Office 365, you're synchronizing your Active Directory to Azure. You go in and you do your logon, you do your single sign-on. Azure Active Directory comes back on-prem to your on-prem ADFS server to do the authentication and to hand out the security token so that the user then has access to their email. If you were to lose your corporate internet connection, so here at CMS, if we were to lose, you know, I think we're on Bell or something like that, if we were to lose that network and have no internet access, we wouldn't be able to authenticate to Office 365 because Azure Active Directory wouldn't be able to come back to our ADFS server and say, you know, and hand out that token to the user. Even if I were to go to the coffee shop downstairs, Starbucks down the street, because Azure AD can't come back to ADFS on-prem, I can't authenticate. Using a hybrid network and virtual machine sitting in Azure, I could put a backup or a secondary domain controller in Azure, and I can put a secondary ADFS server in Azure so that if I can't connect to ADFS on-prem, that it fails over to ADFS in Azure, and I still get connectivity from the coffee shop or from home. That's some of the scenarios where we see these hybrid networks. And so we'll get into the networking capabilities here. And And so in this case here, what we'll see, we're going to go through, we're going to finish off the last demo. So our virtual machine in Azure should now be running. we can do some configuration and get some remote desktop connectivity to that system. And then we're going to build the network. We've kind of done things backwards. Normally when you build a data center, you build the network first and then put the machines in place. We worked a little bit backwards here. We're going to build that virtual network within Azure, and then we'll tie it to our on-prem network and some of the different scenarios you have in play there. So we can see here our virtual machine is now running, which means it's been deployed, and I can see here CPU percentage, and I can go through kind of the dashboard and get just an overall look at the machine here. We'll see the DNS name, the host name, its public IP address, its internal IP address. This is just sitting on the Azure network, Azure Virtual Network, but publicly I have access via this IP address. So I'm actually going to just copy this for now. So I can go in and do some monitoring. Again, CPU, we're not going to see a lot of because it's been running for, I don't know, 2 minutes maybe. Under endpoints, I can see here I've got because I enabled remote desktop remote PowerShell, we've got that endpoint. So we can see here the private port and the public port for that protocol. For remote desktop, we'll see here the private port is the standard 3389, but the public port is a different port. And so if I go in with RDP, well, it's not the RDP that I wanted. Port number there. 5335. Should be able to connect via RDP. Fingers crossed. There we go. So this is our Azure-based virtual machine that we're logging into, and so at this point now I can go and do all my sort of configuration of this virtual machine, whatever I need to do in this case. If I wanted to, I can add another endpoint. So let's say this is going to be a web server. So I need to open up a port. I can say, you know what? Web, it's protocol, public port is 80, private port is 80. What I can't do is I can't say, you know what, this is HTTP. And as long as it's HTTP traffic, let it through. I have to do, port by port. I can't just say let all HTTP traffic in. But I can go ahead and enable web traffic in this case here. What this is doing is it's doing a couple different things, and it'll take a minute or so for this to take place, because not only is it configuring the firewall on the Windows server that we've got running, but it's also creating all the routing rules and all the firewall configuration within that data center and within those affinity groups, and basically doing all that connectivity. So if you think of within your data center, well, I need to allow traffic in. You need to do all your sort of external firewalls and internal firewalls and do your routing and all that. That's really kind of what's taking place here. But my VM is up and running, and I can do what I need to do to this particular VM now. So that takes care of that first demo. Now from a networking perspective, we've got basically a couple different types of things to configure here. We've got our virtual network, which is our Azure network, and we can move our virtual machines then in Azure onto that network. And then there's our local network, which is going to identify our on-prem network, and that then gives us the ability to build that connectivity. So the first thing I need to do is create a new network. So we'll call it CMMS3. It's going to be part of the same affinity group. And what we'll see is as we build this network, we'll see this network preview kind of build out from that. We'll be able to see the configuration of that network. DNS servers and VPN connectivity. So by default, we're using Azure for our DNS and our DHCP and all that. But I can bring this on, you know, into my virtual network that I'm creating. So instead of using Azure for DNS, you know, I'm going to create my own DNS server within Azure. And I'll just give it a name. I already have a name in here. I should. cmms3.dns and give it an IP address. One thing to note, in our virtual network, it's going to give us our own private DHCP server. I can't run my own DHCP within Azure. It's going to use its own sort of DHCP server. This will just be a specific one for our virtual network. I don't know why, but they decided to use .4 as the first IP address of that DHCP scope. So when I'm creating a virtual machine, that first virtual machine, so our DNS server, in this case here, that first virtual machine is going to get the .4 IP address. So I'm going to use the 10.0.0 IP range, and it'll be .4. So that gives us our DNS server. At this point here now, I'm going to create our site-to-site VPN. So our local network is CMS SIE Corp, which is our local network here. I can create a new local network if I'd like, but this just identifies, you know, the public IP address for our router here. Azure supports 3 different types of devices: Cisco devices, Juniper devices, and a Windows Server 2012 routing and remote access server. So those are the 3 different types of devices. So we'll select our network, create our subnet. So this is our address space. Oops, I want to change this here to 64. And I'm going to add my gateway network. Click on OK, and it's going to go ahead and it's going to create those networks. And once that's done, the last thing then is to actually go and creating all the virtual networks and creating a config file. And that config file then I can download. I can specify what device I have. And I can download that config file. And if I've got a Cisco device, I just upload that config file into my Cisco device. And once that's uploaded into the device, then Azure will initiate that connection. So the connection is always initiated from Azure to your on-prem router. And so it's a process that can actually take a while, because it's going to take a while to create the network. Once the network is created, then I can export that file and configure my router on-prem. And then it's kind of I haven't really said what the cycle is, but it just kind of tries every so often. I don't know if it's every 5 minutes, if it's every hour, if it's once a day, but it tries to initiate that connection. And so my network is created here. Go into my dashboard, and here I can download my VPN script. So we can see here the gateway network. It's not created yet because I need to download this VPN script. So I'm going to say Microsoft RAS 2012, and I'll save it to the desktop. Saves as a config file. And once I've got that config file saved to my desktop, where is it here? There's a couple things that need to be edited in here. Basically what I need to provide is my Azure Gateway IP address. So that was, we'll go into configuration here. Here it is, 10.0.0.8 is my starting IP for my gateway network. So I got to go and update this file. And then this is actually, because it's routing RAS server for 2012, it's a PowerShell script that I run against my RAS server. And once that is done, then that connectivity will sort of kick off at some point. And then we'll have that hybrid network, and then I can take my virtual machines now that are running here and I can go into the configuration, and I can, I need to wait for that gateway network to be supported. I can then add that virtual machine onto that particular network and join it to my Active Directory domain, make it a DNS server, and all that fun stuff. Now, one thing to note here, we can see our storage account was created, and here's the storage name. And if I go into the dashboard, we can see here our different storage services, and so I can access the data through those URLs. I can configure monitoring of my storage, and here's where I can sort of enable or disable the geo-replication, enable logging, the types of logs that I want to create. And then from a container perspective, I can see it's created a container called VHDs, and I can go into that container and we can see the name, and this is the URL for that VHD for our virtual machine. So I can get all that information. And now I have some items created. I've got a virtual machine created, I've got a virtual network created, and I've got a storage account created. And as I sort of build this out, I've got the ability to manage that. So just to kind of summarize, I got the thumbs up from Diana that lunch is there, so I don't want to sort of get in between you and lunch. There's a couple things just to kind of summarize as we get into finishing off this section and getting into the next session. Basically, from a private cloud scenario, it's Windows Server 2012 and System Center 2012 from the Microsoft perspective that really kind of builds their private cloud scenario. Surprise, surprise, it's Microsoft Technologies to build the Microsoft Cloud. That being said, we have built these types of scenarios using VMware as the virtualization platform. So everything System Center, managing the VMware infrastructure and providing those same types of services. But private cloud is really kind of begins, where you're at now and what your sort of short-term goals are, and kind of growing it to meet those long-term needs and business requirements. Azure VM and Azure Virtual Networks are fairly new technologies. Again, these have been out since MMS, which was sometime in April, middle of April. So they're fairly new. We've been using it here for testing, and it's probably something that most organizations will see, starting to do some testing and maybe sticking up a virtual machine up there or building that virtual network and moving a test machine up there, taking one of those sort of low utilized non-important servers that we can't get rid of, but we don't really care for it too much, and moving it up into Azure and getting some experience with how that works. But like as Brian said, we're in the very beginning stages, and as we kind of go through the next 3 to 5 years, if we were to do this in 2016, 2017, I'm sure everybody here will have a few production machines sitting in Azure or sitting in some public cloud offering for sure.